Good morning. Rational and irrational numbers are a little bit tricky. And so we're going to look at a graphic organizer, and each one of you guys have this graphic organizer that you can look at. Before we get started, though, let's review what some of these numbers mean. Real numbers. Real numbers are basically, it's either rational or irrational. There's nothing more to it. It's a real number. So some examples are 4, -7, 0, and the number 2/3. Next, rational. What is rational number? A rational number is any number that can be in the form of a fraction where two numbers are integers. So any real number, the number 3, can be a fraction over 3 over 1. Therefore, it's a rational number. 12/6. If you take 12/6 and you reduce it, you're going to get the number 2. And so it's a real number. So we just got to remember any real number is a rational number. Irrational. Irrationals are those numbers that are like a little bit crazy. They go on. They repeat. They don't repeat. They're not terminating. They're like numbers like pi. Numbers that go on forever. I call them they're crazy because they look so weird to us. Integers. Integers consist of natural numbers. 0 and the opposites of the natural numbers. So 4, the opposite of 4 would be -4. -7, the opposite of -7 would be 7. 0 is an integer. So those are just some examples. And whole numbers. Whole numbers consist of natural numbers and zeros. So 0, 1, 2, 3, 4. Those are all natural numbers. And this, I shouldn't have 4 twice. I should have 4 one time, and that should be 5, or that one could be 3. But it's okay that I have 4 twice. Going back up to our chart here, then our graphic organizer, and if I wanted to type something in for rational numbers, what are some things that you think I could put in for my rational number? Think about it, look at your class notes, and let's decide what are some things I could put in for my rational numbers. If you said fractions, you're correct. If you said terminating decimals, you're correct. If you said repeating decimals, you are correct. The word terminates means to stop. So decimals that stop would be a terminating decimal. Next, if you have 0.5, that would be a rational number. If you have 0.333333 and it repeats, that would be a repeating decimal, so it would be rational. Another example would be 2/3. If you simplify 2/3, you would get 0.6666666, and therefore it is a rational number. So all of these are your rational numbers. So let's give it an arrow so that we remember that those are all rational numbers. Let's look at integers. Integers we already talked about, but just in case we forget, an integer is our whole numbers. Oops, a little bit too big, Mrs. Reinhardt. Our whole numbers, they are whole numbers and their opposites. So let's think of some examples of that. Some examples would be -3 and 3. -2 and 2. And we got to remember that we always have to include 0 in this. 0 is always an integer. Let's go down here to our whole numbers. Our whole numbers, once again, are numbers that consist of natural numbers and 0. So I come up here, I'm going to draw my line so I don't forget that it goes to that. I'm going to click here, make this smaller. So then let's go ahead and look at our whole numbers. Some examples of our whole numbers would just be 0, 1, 2, 3, 4, 5, 6, and we could go on and on and on. So those are our whole numbers. Let's go down here to natural numbers. Natural numbers. We will not include 0 in our natural number, but we will include our positive numbers. So we would include 1, 2, 3, 4, 5, 6, and etc. We can go on and on and on. And lastly, our irrational numbers are numbers that are a little bit crazy. I like to call them crazy numbers because pi is one of those numbers that go on and on and on forever. And that's a little bit crazy to me that it looks like that. So that's why I call it crazy. So we're going to go here to our irrational numbers. And we're going to give us some examples of our irrational numbers. So, irrational are our non-terminating decimals. It's also non-repeating decimals. And we also have pi, the square root, square root of 3, the square root of 2, and a decimal that would look something like this. 3.1212. 2, 1, 2, 2, 2. If you see something that looks like that, it's not repeating. And it goes on. It's a crazy number. Therefore, it is a rational number. Please make sure you fill out your graphic organizer to look something like mine. Therefore, it's a good study assignment. And you're able to review what rational, integers, whole numbers, natural numbers, and irrational numbers are. If you have any questions after this short video, feel free to come up and talk to me, and we can work more on it. If you would like to use this is a Glockster, which is a poster that was created. If you need to look at this for further examples, you are more than able to look at it. It is set up for download on the Google Classroom. There's more examples of what irrational numbers are, rational numbers. It gives it another diagram for you to see what natural numbers are, integers, rational numbers, and real numbers, and irrationals. So if you need to, take a few minutes and look at this and become familiar with rational, irrational, whole numbers, natural numbers, and integers. So now let's come back to our warm-up activity that we did at the beginning of class. At the beginning of class, I asked you to put these numbers where you thought they belonged onto our on each one of those sections. So I have a couple here. I have 15. I have 12 12s. I have 0.240 and 4.157. I have negative 17 eighths and negative 2. And I have a square root of 2, and I have all kinds of things in my decimals and my fractions. Is there anything now, let's look at it. Is there anything now that you would like to change? Because we reviewed, we know what positive, integer, negative, whole numbers, decimals, and fractions are. If you think you want to make a change, I want you to go ahead and take 2 minutes to do this. Make any change that you think that you need to do to make this more correct. Here is a students in our classes rational and irrational chart that we did for warm-up, and this is where they have their answers. So let's discuss a few of them. 12 12s. If I would solve 12 divided by 12, you should get 1. That is true, a positive number. That is in the correct spot. Very nicely done. The square root of 16. If I was going to do the square root of 16, I would figure out that 4 times 4 is 16. So my answer would be 4, which is an integer. So that is good. Another integer is 0. 0 could have been an integer. It could have been a whole number. It could have been just those two, integers and whole numbers. These are negative because they have a negative sign in front of them, so that was very good. This is a whole number. Now, once again, square root of 16 could have been down here to the whole number as well, and so could have 0. Decimals, these are all decimals if you would figure them out. The square root of 2 is a decimal, and pi is a decimal as well, and these are both our fractions. So if you have something similar to this, you did it correctly, and you are now getting more familiar with numbers. Nice job.